Design your application using Cloud Data Store with these considerations in mind. Always use UTF-8 characters for namespace names, kind names, property names, and custom key names. Non-UTF-8 characters used in these names can interfere with Cloud Data Store functionality. Do not use a / in kind names or custom key names. / in these names could interfere with future functionality. Avoid storing sensitive information in a Cloud Project ID. A Cloud Project ID might be retained beyond the life of your project. The examples show creating a key with kind task using a key name sample_task as the identifier, recommended, and sample/task, not recommended. By design, Data Store does not handle high amounts of writes to a single entity group. To design for this characteristic, the recommendation is to shard entities. If you update an entity group too rapidly, then your Cloud Data Store writes will have higher latency, timeouts, and other types of errors, known as contention. Avoid high reads or write rates to Cloud Data Store keys that are lexicographically close. Because Cloud Data Store is built on top of Google's NoSQL database, Bigtable, it is subject to Bigtable's performance characteristics. Bigtable scales by sharding rows onto separate tables, and these rows are lexicographically ordered by key. Gradually ramp up traffic to new Cloud Data Store kinds or portions of the key space. You should ramp up traffic to new Cloud Data Store kinds gradually in order to give Bigtable sufficient time to split tablets as the traffic grows. Avoid deleting large numbers of Cloud Data Store entities across a small range of keys. Bigtable periodically rewrites its tables to remove deleted entries and to reorganize your data so that reads and writes are more efficient. This process is known as compaction. When performing a large number of deletes for a range of entities, if those entities have an index on a timestamp field, Data Store will store those entities closely together. When those entities are all deleted, performance for queries in that part of the index will be slower until compaction has been completed. You should use sharding or replication for hot Cloud Data Store keys. Replication can be used to read a portion of the key range at a higher rate than Bigtable permits. You should use sharding to write to a portion of the key range at a higher rate than Bigtable permits. Sharding splits a single entity into many. Data Store and Bigtable will shard automatically, but if your application requires more writes than Bigtable's limits, you can shard manually. In the example, because of the need to write frequently to a key range, in the customer kind, it has been sharded to improve performance. The sharding could theoretically be based on customer region or regions. Keep the following in mind when sharding. Transaction throughput is limited to 1 write per second per entity group. Split frequently updated entities across multiple kinds. In order to avoid contention with high writes, you should shard counters. To update an entity faster than the recommended 5 times a second, you can shard counters. To reduce contention, because serialized writes stack up and start to time out, you would build a sharded counter. You would break the counter up into n different counters. When you want to increment the counter, you pick one of the shards at random and increment it. To find out the total count, you would read all of the counter shards and sum up individual counts. Increasing the number of shards will increase the throughput you will have for increments on your counter. For more information on sharding counters, please see the reference available in the downloads section below.